All right, everybody take a quick look at page 1 and say, I think I know all that. I know you haven't been here, but have you been watching the videos? Okay. So right here, you could actually see probably 6 or 7 vocabulary words just on this one page alone. So you can almost figure that out. Now, let's go to the next page. The next page is where we're classifying, and we finished that last week. And we found out that for first year chemistry, we have 5 different types of chemical reactions. They have 5 different categories, you might say. Well, there's also 5 new vocabulary words. So now we're up to around 10, 11, 12. So you can almost figure out what they're going to be. All right, now let's go to the other thing we did last week is we classified all the ones here. How about number 10? Do you remember that one? Take a look at number 10. This is the one to be what's called one of the harder ones. Yes, I'm sorry. Which one? I'm sorry, say it again. Oh, single, this right here? Okay, let's take a look. What do you think? Is it single replacement? Oh, here, help me out. Wow, that's loud. You know why I don't think it's single replacement? Because single replacement, you would have a single element. I'm sorry. You'd have an element by itself and then a compound, and then this would kick out and have a single element. So this is a little different than that, isn't it? What do you think? Yes. I like that. See how we take A plus B and make AB? That's very good. So I believe you're going to do well on vocabulary words. I believe you're going to do well on classifying. And then the last thing is, what are the tricks? What are the tricks of balancing, okay? So let's go over this again. Trick number 1, the odd-even mismatch. And we did this, and I'll do some more. Look at number 3. If I scan through here, I see an O2 here, and I see an O3 here. And this is the even odd. You'll never get an odd number to equal an odd number, equal an even number. Wow, it's hard to say. So what we do is, what's the smallest number that 2 and 3 go into evenly? What's the smallest number that 2 and 3 go into evenly? It's 6, isn't it? So what times 2 is 6? 3. And what times 3 is 6? 2. Now what I'm going to do is, because this is trial and error, okay, we have to watch now. How many oxygens on the left side of the arrow? See the arrow? How many oxygens now? Everybody say it. Everybody. 6. That's right. Now how many oxygens on the right? 6. So they're balanced, aren't they? But what happened when I put this coefficient? Oh, there's no vocabulary word. What happens if I put this 2 here for iron? What's 2 times 2? That's 4, right? So now I have to have 4 irons. And because it's trial and error, I always check to see if it can be reduced. Can you reduce this? 432, can you reduce it? Is there any number that goes into all those evenly to give you another set of whole numbers? No, we're done. That one's done. Everybody understand the odd even mismatch? If not, we had another one over here. We did an odd even mismatch over here on this side. And let's do one more. Let's everybody do number 4. I'm trying to get you to get confident, okay? If you can build confidence in balancing equations, you're going to want to take the quiz. What? Yeah, you're going to want to take the quiz on Wednesday and say, I want to show you. I'll show you I can classify. I'll show you that I can balance an equation. Okay, so let's try it. Everybody scan through there, and again, O2, O5. Wait, that's a 3. Where's the other one I wanted to do? Oh, okay, let's do both of these. Both of these are odd even mismatches. Let's everybody try it. Try number 4 and 6. See if you can get both these right. Now, if you'll raise your hand, okay, there's a small class, isn't it? This small class? If you'll raise your hand, it might be something that's bothering you right now. I know it's a Monday. I don't know what you did this weekend. I don't think you talked about chemistry during lunch. So maybe your mind's not here yet. But you should be able to get these 2 right. And if not, just raise your hand and say, I'm not sure what you mean by odd even mismatch. Is everybody done? All right. Julie, did you get this done? How about number 4? Got that done? Still working on it? One more time.
Yeah, actually, I don't know.
Okay, so I'll help you, okay? As you go through here, see the arrow? These are the reactants, and this is the product. Now, I have to make the number of each kind of atom match on the left and the right, okay? Because you can't have atoms disappear out of nowhere. That's called the law of conservation of matter. You can't have atoms disappear from the face of the earth. And you can't have them show up out of nowhere. So look right here. I scan through here. I see there's 1 iron, there's 2 oxygens, and then 2 irons and 3 oxygens. I see the odd, even. See that? You'll never get an odd number to match an even number unless I do this little trick. What's the smallest number that 2 and 3 both go into evenly? Okay. What times 2 is 6? And what times 3 is 6? Now this 2 distributes over everything. So now you have 2 times 3, you got 6 oxygens. How many over here? That's balanced. They call it balanced. And then how many irons do you have? 2 times 2, 4. So put a 4 right there. What do you think? And you always check to see if it can be reduced. No, that can't be reduced. I'm done. All right, how about number 6? Layla, how about this one? Do you see an odd even mismatch there or not?
Yes.
What are you going to do about it? Tell me what to put in front of it. What coefficient goes here?
I don't know. I don't know.
Okay, did you hear what I was just saying to Julie, though? Do you see an odd even mismatch here? See where it says H2, what's this say? It has an H3, doesn't it? So what are you going to put in front of the H2? Yep. 3 times 2 is 6 hydrogens. How are you going to get 6 hydrogens over here? 2. Okay. Now, but that gives you how many nitrogens? Look at this. How many nitrogens? 2. And I had 2. See that?
You know how to do it, like, why did you do it to 6?
One more time, sorry.
Why did you do it to multiply to 6?
Where's the 6 though?
I thought you said it has to multiply to 6.
What I saw was, when I saw H2 here and H3, what's the smallest number that 2 and 3 both go into? 6. So if I put a 3 coefficient here, 3 times 2 gives me 6 hydrogens over here. 2 times 3 gives me 6 hydrogens over here. But then the 2 in front of here, that's really N1H3. Does everybody know that? This is really N1H3. 2 times 1, I have 2 nitrogens over here. How many over here? See that? That's 2 nitrogens, isn't it? And so they balance. So everything's balanced, and can I reduce this? As long as, see that there? That's a 1. That's a 1 coefficient. When you're in math class and you say x squared, what's the coefficient? What's the coefficient of x squared? Again, this is simple math. What's the coefficient for x squared? 1. It's understood 1, isn't it? Same thing in chemistry. If you don't see something in front of there, it's 1. The coefficient right there is 1. So I can't reduce it. If I have a 1 anywhere, I can't reduce it. All right, let's go back to trick number 2. Let's go back to trick number 2. Trick number 2 is when you see a polyatomic ion on the left and it stays as a polyatomic ion, treat it as a single atom and balance them. Now, the one we did over here last week, look right here. Scan, scan, scan. Pretend like you don't see these big fat numbers, okay? Scan, scan, scan. I see 1 sulfate here. 1 sulfate here. But how many sulfates here? 3. So if I had 3 sulfates, I put a 3 here. That gives me 3 sulfates. But how many coppers does that give you? 3 times 1. So I have to put a 3 here. 3 coppers, 3 coppers. And I have 2 aluminums on this side of the arrow. I had to put a 2 here for that. Can I reduce that? You say no, because the coefficient here is 1, isn't it? Hey, can you guys shake your head or do something where or raise your hand and say, I don't understand what you just did. We're going to practice what I just said. Let's go down to, okay, here we go. Let's do number 5. Let's do number 5 on this side and scan through there. do you see a polyatomic ion on the left and on the right? Does it stay? Is it? Does everybody know what those are called? You can't forget what these are called. All right, Zach, help me out. Zach, on the left side of the arrow, I see one lead. How many nitrates do you see? See this thing here called nitrate? How many nitrates do you see? How many? Okay, now nitrate's like my fist, okay? Now see this parentheses? How many fists do you see? 2. So I had 2 nitrates on the left side of the arrow, right? Let's go over here. How many nitrates are right here? Don't say 3. How many nitrates are over here on this side? NO3 is my fist. So there's 1 nitrate here, 2 nitrates here. So what are we going to do about it? See now? Now how many nitrates do we have? Does everybody see that? But that gave, how many, Zach, help me out. How many potassiums does that give you? 2, right? 2. See? That's K1NO3. So it gives you 2 potassiums. How about on the left side of the arrow? How many potassiums? 2, right? 2. They balance. How about 1 lead? 1 lead. And 1 chromate? 1 chromate. I think we're done. Can we reduce this? Of course not. See all these 1 coefficients? All right. What do you think about trick number 2? Let me see if there's another one that has the polyatomic ion trick to it. Okay, let's go. All right, let's go to trick number 3. Trick number 3. When you see blah, 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 hydroxide, when you see hydroxide on one side of the arrow and you see water on the other side of the arrow. All right, so if you see blah, 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 like sodium hydroxide on one side of the arrow and you see water on the other, if you will write the water as HOH, number 1, it makes it easier to classify and it makes it easier to balance. All right, so let me show you one. Okay, we did that one before. Look at number 8. Everybody look at number 8. Now, as I scan through here, see there where it says water here? And then what's this guy? Sodium hydroxide. Well, that's when I would use this trick. I don't always write HOH for water. I only do it when there's a hydroxide on one side. So I'm going to write water as HOH. All right, now stay with me and let's see what's going on here. Go through here. How many sodiums are on the left side of the arrow? How many sodium? Everybody. 1. How many on the right side of the arrow? 1. Okay, good. How many hydrogens on the right side that are not in hydroxide? How many hydrogens are not in hydroxide? Everybody. Raise your finger because I can't hear everybody. Tell me. 2. How many hydrogens over here not in hydroxide? How many hydrogens not in hydroxide? 1. Didn't I see that? So what am I going to do about it? I'm going to put a big old fat 2 there, big coefficient. Now how many hydrogens are not in hydroxide? 2. 2. But how many hydroxides does that give you? How many hydroxides does that give you? 2. How many hydrox over here? Only 1. How are you going to fix that? Now I have 2. And then we have one more thing to do. How many sodiums does that give you? How many sodiums? 2. Uh-oh. Now, be careful. Can I reduce it? Oh, almost, except there's a 1 there. No. If you have a 1 coefficient, you cannot reduce it. Yes?
When you say reduce it, like, what would you do if you had to reduce it?
If what now? Oh, okay. Because it's trial and error, somebody could have said 4, 4, 4, 2. If you'd had 4, 4, 4, and 2, it still would have balanced. But you should notice if you have 4, 4, 4, and 2, you can divide everything by 2, can't you? Is that what you're asking about? What would it look like? All right, so what do you think? One more time. If you see hydroxide on one side and water on the other, write the water as HOH, and it'd be easier to balance and classify. Okay, let's see if I can find one over here. All right, here we go. Let's do number 3. Let's balance number 3 over here. Now, you have to do this on your own. You have to practice. You have to push yourself. Got it? I say, okay, what do I notice? Well, I do notice there's a hydroxide on the left, sodium hydroxide, and I notice there's a water there. So I think I'll write the water as HOH. If I can get your brain to think of this as A and hydroxide as B, and this is C and sulfate is D, if I can get you to think like that, you'll very quickly see this is a double replacement reaction, and then you'll be able to balance it. All right, let's try it. Look over here and scan, scan, scan. I notice how many sulfates are on the left side of the arrow. Hey, May, I can't see you, okay? Can you put your folder down? Can you move over so I can see you? May, how many sulfates are on the left side of the arrow?
Is that 4?
No. Look at me. That whole thing's a sulfate. Get it? SO4 is my fist. How many fists do you see on the left side of the arrow? SO4 is a sulfate, is my fist. How many fists do you see? That's right. How many sulfates on the right side of the arrow? You're 1. So sulfates are balanced, aren't they? Now we go over here. How many hydrogens do you see that are not in hydroxide, May? So that means don't look at these hydrogens. How many hydrogens are not in hydroxide on the left side of the arrow? Huh? Does that say H2? Can you see, right? You want me to magnify it? Okay, sorry. Let me magnify it, okay? Okay. You have a sheet, don't you? You have a sheet with you?
Yeah.
Do you have the homework sheet? Okay. Okay, so now, does this say, where am I at? Here. Does this say H2SO4?
Yes.
So how many hydrogens do you have that are not in hydroxide? 2. See that? H2. Okay, how many hydrogens over here not in hydroxide?
2.
How many?
2.
I only see 1. See, it's right there. See right there? So how do I do that? What am I going to do to balance it, May?
Add another one.
But how do I add another one? And when you balance an equation, you're only allowed to change coefficients. You already have the formulas written correctly, so I'm going to put a 2 here. Now watch, how many hydrogens do you have that are not in hydroxide, May?
Not hydroxide?
Yeah.
What is that?
See, I'm covering them up so you can't look at them. How many hydrogens do you have on this side of the arrow that are not hydroxides? 2. How many on the left side of the arrow not in hydroxide?
2.
So those are balanced, aren't they? Sulfates are balanced. Hydrogens are balanced. Now, May, you're almost done. How many hydroxides do you have?
1.
Okay, but see that big old 2 here? It would have been 1. If it would have been 1, but there's a big 2 in front of there, right? Can I show you what this means? Here. Here's HOH. Get that? You know what 2 HOH means? There. That's 2 HOH. See, I got 2 of them. If I had 2 HOHs, how many hydroxides would that give me? 2. So it's 2 times hydroxide, 2 hydroxides. So you had 2 hydroxides on the right side. How many hydroxides over here? 1. How are we going to fix it? Big coefficient, right? But then how many sodiums does that give you? 2. How about over here? 2. Now they're balanced. Everybody get that? Scan. Can this be reduced? No. What do you think? And I promise you, the more you do, the more you practice these, you'll just get better and better and better. Okay, let's show you another trick. Another trick that I have is too many things have oxygen. Don't balance. Don't balance oxygen until last. Or I should say balance oxygen last. How about that? I'm going to show you one here. Do you see this guy up here, number 4? If you were trying to figure out which element would you try to balance first, what's the one you should not try to balance first? Look at this guy. He has oxygen in him. So do I. So do I. So do I. Don't do that one, okay? Don't pick that one first. Okay, now what do you want to pick? Kyle, help me out. Kyle, if we're going to do number 4, and I'm not going to try to balance oxygen first, what do you want to go after now? Hydrogen or carbon? Okay, let's try it. Now on the left side, Kyle, how many carbons on the left side? 6. How about on the right? How many?
2.
How many? Try it again. Do you know that CO2 means C1O2? So I had 6 carbons here. How many on this side? Only 1. How do I fix that? Put a big old fat 6 there. Get it? Now I have 6 carbons on the right hand side of the arrow. I have 6 carbons here. All right, Kyle, do hydrogens now. How many on the left?
12.
Yes?
1 on the right.
How many?
1.
How many?
Alright, I guess 2.
What's H2O mean? That's 2, right? So we want it to be 12. So what are you going to put in front of here, Kyle? 6. Now 6 times 2 is 12. 12 hydrogens. 12 hydrogens. See, now by waiting and leaving oxygen to the end, now I can play a little game here, okay? What is 6 times 2 oxygens? Everybody look at me. You got to pay attention. What's 6 times 2? 12 oxygens. And what's 6 times 1? This is H2O1, isn't it? So I have 6 more oxygens. How many oxygens do I have on the right-hand side? 18. I have 18 oxygens on the right. I need 18 on the left, don't I? Well, here's 6 of them. How many more you want? I need a total of 18 on the left. I've got 6 right here. How many are left? 12. How are you going to make 12 out of this? Does that make 12? Let's try it. 12 plus 6, that's 18 oxygens. 12 plus 6, that's 18 oxygens. Can you reduce this? No. You know why? Because there's a 1 right here, isn't there? What do you think? Okay, and I have one more trick, and it will be done. Before I show you this trick, I'd like you to try something, and you know what? I know it will frustrate some of you. I'm going to have you do something that I know will frustrate you. Even if you think you're catching on, you said, I'm catching on to this. I would like you to balance number 7. I want you to, and I'll give you a minute, I'll give you a whole minute to try to balance number 7 on your own. See if you can balance number 7. And then I'll show you a little trick. Anybody got it yet? And when I was in high school, and I remember we were balancing equations, even in college, and I'm trying to balance this, no one told me these little tricks, you know? And I was just kind of doing the best I could. But these always frustrated me. And you can keep working if you want, but I could give you another 10 minutes and you probably won't be able to balance it. But I'm going to show you a little trick, okay? Everybody ready? If it is a combustion reaction, if it's combustion, how do you know it's combustion? We have carbon, hydrogen here. You're going to burn it. That means add combine with oxygen. And what are the two products? carbon dioxide and water. If you have all of that, you're a combustion reaction, right? So I want to show you a little trick. You already know, can everybody look up here for a second? You already know not to do oxygen first, don't you? There's too many things with oxygen. So a lot of people like to pick carbon first. I'll just show you what happens here. See that 8 here? I'm gonna put a really faint 8 here because I might have to erase it. So you're gonna put 8 here, aren't you? Because that's gonna balance out the carbon. And then what are you gonna do here? 18. How are you gonna make this 18 hydrogens? And you're gonna say, you think I'm smart? I'm smart. 9 times 2 is 18. I know what I'm doing. And I'm gonna show you something, all right? Let me see how smart you are. All right, everybody looking at me? Show you how smart you are. Do you know that any whole number I put in front of here times 2, what is any whole number times 2? Is it odd or even? Pick any whole number you want times 2. Will that give you an odd or even? And you should be able to sit here and say, oh, I like 7. What's 7 times 2? 14. Even. I like 3. 3 times 2. 6. Even. No matter what you put in front of here, you have to have an even number of oxygens, don't you? It has to be even. So guess right here. If you put an even number in front of carbon dioxide times 2, you get even. But if you put an odd number in front of carbon dioxide times 2, even, then what's wrong with that? Here's the problem, right here. If you put an even number here, it'll give you even number of oxygens. What's even number plus an even number? You ever try that? Take 2 even numbers. 4 and 10. What's that give you? Even. 6 and 8. Even. What is an even number plus an odd? What if you put an odd coefficient here? Let's take any even number and add any odd number to it. Do it. 4 plus 3, 7. Odd. You cannot have an odd number of oxygens on the right. You can't. Because it has to be even. So what's the trick? Everybody ready? See that 9? How many of you put a 9 there? I would have. Here's my trick. For combustion reactions, don't put an odd number in front of water. Instead, double the odd number. Double it. So CS9, I'm going to get rid of that and put 18. I'm going to double the 9. Do not put an odd number in front of water for combustion reactions. That's the only time I told you not to put an odd number in front of water, okay? Now watch. Watch what happens here. What's 18 times 2? How many hydrogens do you have on the right side of the arrow? What's 18 times 2? 36. But how are you going to get 36 over here? What times 18 is 36? Okay, so I'm going to put a 2 there, right? Now you see what happens. Now I have 36 hydrogens on the left, 36 hydrogens on the right. But now what happened to my carbons? How many carbons do I have now? 16. So I got to go back. I knew I was going to have to change that. Okay, now, hold on to your hats here. Here we go. How many oxygens are on the right? 16 times 2 is how many? Okay, ready? And what's 18 times 1? Oh, man, this is big. What's the total number of oxygens on the right-hand side? What's 32 plus 18? Daniel? 50. Man, how am I going to get 50 oxygens over here? What do you think? Something times 2 is going to give 50. What is it? Woo! You know that most of the time when you balance the equation, 6 is probably the highest number you ever come up with? But if it's combustion reaction, you can get some pretty big numbers. What do you think? All right, now, when I grade this homework assignment, even though we did a lot of these, let's go back up here. Did you get number 1 done? Is it done? Did you classify it and balance it? Classified. And you know what? What if you don't have to change any of the coefficients? What are you required to write? On the quiz on Wednesday, if you think it's already balanced, you write balanced. Got it? How about number 2? Classified. Uh-oh, wait a minute. Is it balanced? What do you think? If it is, if it's already balanced, what are you supposed to write? This is what you do. I know I did a lot of it in class, It's your job to finish this page. Okay, how about number 3? Is it classified and balanced? What do you think? I already know these two are done. How about number 3? Yeah, we did that. How about number 4? Classified, balanced. How about number 5? What do you think? Classified, balanced. 6. Hey, we did that. 7. We just did that. 8. We did that. 9. 10. What about number 10? It's classified. Is it balanced? Now here, I would not write water as HOH here because I said if it's water on one side and hydroxide on the other, I don't see hydroxide. Okay, everybody balance this real quickly. Go ahead, balance. Yes. Wait, you have to balance it, then you can go. Tell me what it is. Tell me what to do. Go, you can do it. Help me. Be the teacher. I want to hear what you say.
There's only one. So like the left side is 2 oxygen,
2 oxygens on the left.
and there's only 1 on the right. So you put the 2 in front of H2O,
Uh-huh.
and that would make the H have 4 H's. So you need 2 in front of the H2O.
Now, can you reduce this? All of them. See, if this had been 2, 2, 2, you could have, but it was 2, 1, 2, isn't it? So you're done. All right, you can go. Thank you. All right, here's what I want you to do. Ready? I'm going to walk around the room. I'm going to walk around the room for the next 5 minutes, and or maybe less. And all I want you to do is work on this packet. So I'm going to walk around the room, and I want you to finish. Huh? As long as you're getting something out of it, okay? If you think the partner's helping you, then yes. Okay? If not, I'll walk around and help you, all right? All right, I want you to work on this page, and I want you to work on the next page too, all right? Okay, and I'll be walking around, and I'll be trying to maybe catch some of your mistakes if you're making mistakes. All right, everybody working on these packets for the rest of the period.